Hi, welcome to the screencast for the 17-117-2 partner quiz. This is the key and explanation for version 1, which is an awful lot like version 2, but they're slightly different, so I'll do a screencast for each. Question number 1 asks, it says, at 793 Kelvin, which is the temperature, the equilibrium constant for a reaction is 39.3. Do the reactants or products dominate in this equilibrium? Explain how you decided. So the 793 Kelvin, the only reason the temperature is included is because equilibrium changes when temperature changes, so the equilibrium constant. So that's the only reason they included it, but we really don't need that to make our decision. What we need is this information right here, which is telling us KEQ is equal to 39.3. Remembering that it's found by taking your concentration of products over your concentration of reactants, because this number is bigger than 1, then we know the products have to be a lot bigger than the reactants are. And that means the products are dominating. And that's what I was looking for number 1 for 2 marks, which is what these 2 pluses here are reminding me of. Question 2, groups did pretty well on. It said if you want to maximize the products of the following reaction, which concentration would you raise? So you want more products and you have to increase something. So if you want to increase your products, you need to either take away product or increase reactant. And since your only choice here is to increase, then you should be increasing either the CO2 or the H2 or both reactants. And that means you'll have more reactant particles to collide, which will mean more product. And again, this was a 2-mark question. Question number 3, volume and pressure get a little trickier to think about. But as you read through the question, let me show you the way I analyze these questions. It says, for the following reaction, should you increase or decrease volume if you want to increase your yield of product? So I want more product. And so if I have to change volume, that is going to have the greatest effect on the more crowded side. So that's the first thing I need to know is which side is more crowded. I've got 2 moles on the reactant side, but only 1 mole on the product side. So my reactant side is more crowded, so it is going to be more affected by a change in volume. So if this is more crowded and it's going to be more changed, I want to see more collisions on that reactant side. So the way to do that is to crowd it more, which means decrease the volume, so the particles are more crowded, and they're more crowded on both sides, but especially on that reactant side where they started out more crowded. So there's going to be more collisions or a greater increase in collisions on the reactant side, and that will end up forming more product. And then number 4, a temperature question. And I just mentioned real quickly, this was a 3-mark question back here, and number 4 is also a 3-mark question. What effect would an increase in temperature have on this reaction? Which way would the equilibrium shift, and does the product increase or decrease? Give your reasoning. Well, heat is listed as a reactant, so that lets me know that heat is a reactant, and adding more heat or increasing temperature will cause more collisions on the reactant side, shift the equilibrium to the right, and increase the amount of product made. And the reason is because it's an endothermic reaction, and heat acts as a reactant and creates more collisions on the reactant side than the product side. And that's 17.